Hello guys, welcome to another video. So in this video I'm going to discuss about the partition coefficient. What is the partition coefficient, what is its formula, and where we use it. So first of all, let's just go at the definition. Partition coefficient is the ratio of the concentration of the solute in two different immiscible solvents or partially immiscible solvents when an equilibrium is established. Now what does this long sentence mean? For example, I'll go with the example that when we are working in lab, you all must have used the separating funnel. I have drawn a diagram here of the separating funnel. So what do we do is we add a organic solvent in this, we add the aqueous layer, that is water, and we add our product or our solute particles in this. And what we do is we shake this vigorously. Right, we shake this vigorously, and what happens is the solute particles I have shown here in red, they start moving from one solvent to another. So for example, if this is my organic solvent, down, let's say it is first is my organic solvent which I have shown in green, and down is the water or the aqueous layer. The organic solvent, after shaking, you will observe that the organic layer always stays up, and here down is our aqueous layer. And after shaking, this solute particles, they start moving from one solvent to another solvent. And when once equilibrium is established, equilibrium means that equal number of solute particles will be moving from one solvent to another. For example, there are 5 solute particles moving to the layer below, so 5 solute particles will be moving to the layer above. So that is how we are saying that equilibrium is established, that equal solute particles will be moving. And this should be immiscible solvents. Immiscible means they should not be soluble with each other. Okay, if they are soluble with each other, then we will not see the separating layers on the separating funnel. So they should not be immiscible or soluble with each other. So the solute molecules will get distributed between the two solvents, that is, the molecules will keep moving between the two solutes. Now what we are saying is, once we shake this in the separating funnel, the solute particles will keep moving between the two solvents. Now according to the solubility of this solute, the solute will have different solubilities in the two different solvents. For example, in organic solvent it may have a different solubility, whereas in aqueous layer it will have a different solubility. So the solute particles will have different solubility in the two layers. So according to the solubility of the solute, some molecules will dissolve in organic solvent and some will dissolve in water or the aqueous layer. Now the movement of these molecules continue till equilibrium is achieved. The movement of these molecules, that is the solute molecules that I have shown in red color, that movement will continue till the equilibrium is established. The movement of molecules will be same between the two solvents. That's what we mean by equilibrium. So here I have shown that this is the concentration of solute X that will be in aqueous medium, and here it will be organic. One should be organic, and the other one will be in water. So then here we have taken the example of ammonia. Okay, so ammonia as we know will be soluble in both, that is our aqueous layer as well as our organic solvent, but concentration in both solvents will be different, right? It will have both, it is soluble in both the solvents, but solubility will be different again in both solvents. Maybe it is more soluble in organic layer or less soluble in water, so solubility will be different for both. So here what we will do is we can write the solute, the concentration of solute particles in organic layer upon the concentration of solute particles in aqueous layer. That will give us the Kpc, or we are saying this as this is the coefficient of partition coefficient. Okay, so this we are getting here as a formula. So we can say that the partition coefficient is the concentration of solute in organic solvent and the concentration of solute in aqueous solvent. So now Kpc is nothing but we can even say the equilibrium constant, because here we are defining this as at the equilibrium, right? So Kpc we can even say it is the equilibrium constant, or it is even called the partition coefficient or distribution constant. Now here for Kpc, for example, we are calculating this Kpc. I have given you some concentration of the solute in organic layer and some XYZ concentration in aqueous layer. So if we get the value of this Kpc or partition coefficient greater than 1, then we can say that the solute is preferably more distributed in the organic layer. Okay, and if we get this less than 1, this partition coefficient value is less than 1 after calculating from here, then we can say that the solute is preferably more distributed or more soluble in the aqueous layer. So thank you for watching this video. Do like, share and subscribe.